Hello everyone. Today we will be discussing the gradient descent cost function. So let us begin. For our cost function, we have some basic notations that we have to keep in mind before starting this derivation. First of all, what is gradient descent? Gradient descent is an algorithm that will help us find the global minima of a function. The main goal of the gradient descent algorithm is to minimize our loss function. And how does it do so? We have a function that we will solve for, and after that the parameters that we get, if we plug in the parameters in the loss function, we will get the minimum value for it. That's the whole algorithm for it. First of all, we have to define the notations. Firstly, our input features and output features. X ith and y ith would be our input and output features respectively. The capital X and capital Y would be our spaces for them. These are column vectors. So x1, x2 till xm, and y would be y1, y2 till ym. You might ask, what is ym? So m here is our training set size, so the total number of features, training set size. Okay, let me just write it. These are spaces, input and output spaces. These are vectors. And also thirdly, we have theta that depends upon j, but we are writing I because there will be I number of parameters that we need to tweak and optimize. So these are parameters. Just a second. Set recording. Okay. These are parameters, and what we need to find is these parameters, the right values for them. We also call them weights. So now let us define our linear function for whom we need to find the parameters. H theta of x is equals to theta naught plus theta 1 x1 plus theta 2 x2 till theta m xm. This is our linear function that we need to find the parameters for the weights. And the cost function for our linear problem would be this j of theta equals to 1/2 summation from I is equals to 1 till m h theta xi minus yi squared. This is our cost function. This is basically the mean squared error. Why so? Because we are defining the error, we are squaring it and then finding the mean. Okay, this is our error. And what is our error? Error is equals to actual value minus our predicted value. Okay, so how will we find the right parameters for this? To minimize this loss function, so our goal is to find the minimum for j of theta. Okay, how will we do this? We will apply gradient descent. What is the basic step we do this? We will start with initial theta, initial value of theta, that is a parameter. Start with initial theta and then iteratively update our theta till we reach global minima. Okay, so the function for updating the theta will be theta j gets updated to by this relation theta j minus alpha times del of j theta upon with respect to theta of j, where j runs from 0 to n. So this is our update rule. Okay, this is update rule. Now let us define how we can solve for this derivative, partial derivative. So now let us derive this. So del of j theta by respect to theta j would be theta j 1 by 2 h theta x. We're doing this just for one training example, squared. So this 2 comes here, this gets cancelled out, so we are left with h theta of x minus y times the derivative of h theta of x minus y. Now we also know that we have to apply the gradient descent algorithm for all the training examples. So there will also be a summation here from I is equals to 1 till m. So this really becomes h theta of x minus y times this, and this updates to theta naught x naught plus theta 1 x1 plus theta 2 x2 till theta m xm. So if we take a partial derivative of this with respect to theta of, suppose, 1, if we take j is equals to 1, so all these values get cancelled out, only this one remains, right? So the final output would be h theta of x minus y times theta 1 x1, that will just rewrite as x of j just a second. I don't know what is happening, but let's just take this elsewhere. Maybe just erase this. Okay, now our final output would be the derivative of j of theta with respect to theta of j is h theta of x minus y times x of j. This is a derivative. So our final update rule becomes theta of j equals to theta of j plus alpha, the learning rate, minus yi plus alpha times yi minus h theta of x minus y times x of j. So this is our update rule, and this alpha, I didn't discuss it earlier. This is the learning rate. We usually take this to around 0.01 or 0.001 depending upon our problem. So yeah, this is the final update rule.